So I'm going to tell you a little bit about what a green roof is, and then I'm going to have the students tell you exactly what they're doing. A green roof is basically an alternate type of roof that goes on a flat building, a flat roof building, institutional commercial buildings like this building. So instead of having asphalt or tar, the idea is you go in there and you put a membrane, a waterproof membrane up there, then you put a thin layer of soil, lightweight soil. So it's lightweight, it's not the stuff out of your garden. They add some pumice or vermiculite or something that makes it lightweight so it doesn't put too much weight on the roof and collapse the roof. Thin layer, plant some plants on it, and turn it into sort of a garden, and that's the roof. And there's some obvious advantages. It's pretty, and it gives off carbon dioxide, gives off oxygen, absorbs carbon dioxide, and it provides a place for insects and birds and that sort of thing. But typically that's not enough for somebody to decide to put that on a building because it costs more. It costs 50 to 100% more than a conventional roof. So their question is, well, what are the other advantages? Specifically, does the building use less energy because we now have a layer of soil which provides some insulation on the roof. Plus we have plants there. And the plants take water and they evaporate, evapotranspiration, they evaporate the water. And now the heat to evaporate the water is heat that doesn't go in the building. So it's postulated that it saves energy in the building, especially in the summer, when you get a lot of evaporation going on. The other thing is that the rain that falls on a green roof, instead on a conventional roof, it just runs right down into the sewer. Now in Portland, we have some of the highest sewage rates in the whole country because we've got the big pipe project going on. So if you can not put as much water through the sewer, potentially you can get a reduction in your sewer rates for the building. So you can save some money there. Then finally, the idea is, well, perhaps when the water flushes across a flat roof, there's all kinds of dust and pollutants that are sitting there, and they dump it down into the sewer, and then that has to be treated. So maybe the water that comes off of a green roof is in fact cleaner. So those three things: energy, reducing the amount of water that goes off the roof, and cleaning up the water that goes off the roof are the things that people want to know about. Do they do that? Do green roofs do that? So it's really hard to measure that out there if you put a green roof in a real building. So we have a simulated green roof here. And so these are simulated green roofs. It's the same depth, same kind of soil, same kind of plants. And what we're looking at are what are the variables that you might affect to make them work better. What kind of soil, how much soil, what kind of plants. And so we're testing different combinations. So we've got two things, the energy and the water. So I have two students here. I'd like to tell you about what they're doing. Eduardo Guerrero is an undergraduate student in mechanical engineering, and he's going to talk about energy, how we measure that. And Debbie Beck is a graduate student in environmental engineering, and she's going to tell you how we're measuring water, both quantity and quality. So with that, I'd like to turn it over to the people who really do all the work around here. Eduardo, why don't you go first?
Hi, Eduardo Guerrero, mechanical engineering undergrad. So what we do in this lab, in order to get a sense of the energy savings, is we try to come up with an effective R value of the green roof. If you're not familiar with R value, if you look at that pink foam insulation there, that's sort of how it's rated, sort of its ability to resist heat flow. And so we're trying to come up with an effective R value for a green roof. How effective is it at blocking heat going into a building? And the way we do that is we have this side, we try to simulate outdoor environment. So there's a heater on that side, and we can try and do temperate climate, really hot climate. So we'll blow hot air over the top of it. We can also control the humidity. This guy here injects steam into the chamber, and so we can come in and do like a nice hot, dry desert environment. We can do the Everglades if we want, just 90%. I think we've gotten it up to 90 degrees, 90% humidity. So nice, good, nasty weather. And then on this side, we have an air conditioning unit. And this sort of simulates our interior office space. And so we'll blow cold air through here. And so now that we have hot air here, cold air here, that drives the heat want to go into this chamber. And what we measure is the heat going into this chamber, and then we measure the temperature of the top and the bottom. And that gives us a sense of what the effective R value of the green roof is. Let's see. On the instrumentation side, so these guys here, these little funny silver cylinders, those are little temperature sensors. Those are little radiation shields, courtesy of graduate student that made them last year. We also have humidity sensors. Those are those vertical cylinders, kind of hard to see. We also measure the surface temperature of the green roof, the middle, and what you can't see is there's temperature sensors in this chamber and these little heat flux sensors. So that pretty much gives us everything we need to measure that R value. So we, as Dr. Spolek said, we try to look at different plants and see what their R value might be, and we also try to see what the effect is of temperature and humidity. And so what we've found so far is temperature has a really strong effect, as you might expect. There's this really high temperature, especially, which really drives a lot of evaporation and a lot of transpiration from the plants, which is thought to be the mechanism that really prevents heat from going into the office space or through a green roof. And we've also tried to see plants that are a little bit more drought resistant, but maybe don't transpire as much water, but maybe will require less maintenance, versus plants that might require a little bit more watering. So that's another direction for the research, is just sort of looking at irrigation rates. So obviously, that's going to factor into the cost of maintenance of the green roof. And is there some sort of optimal that we can achieve? So that's what I got on the energy side. If you guys have any questions.
So what have you discovered in terms of the most effective R value?
We found that soil depth doesn't have a huge impact on the energy side. Plant type seems to have a strong effect, well, a relatively strong effect, but temperature has a really strong effect. So which is kind of perfect when it's hottest outside. That's when the plants in the soil, the evapotranspiration is at its highest, which gives you your highest effective R value. So, winter time, you're not going to get that same evapotranspiration effect. And so we found that, winter time, as far as a green roof being a good insulator, that's not going to be the case. So you're really going to see savings for summertime cooling.
So in terms of substituting, for example, that stuff's very expensive. And
right.
Substituting green roof to offset the cost is not something that we've ever really tried to do, but particularly because of the winter season, when it's saturated, the roof actually becomes a thermal bridge as opposed to insulation.
Right. So there is that. So I think you have to.
That you get anything in the winter.
I think looking at it averaging it over a year on the energy side, you see an improvement. So, but that has to be, you really have to look at it over an entire year's time. And I think in order to really make it worthwhile, you have to look at other potential savings. So looking at it just from one standpoint alone, I think it'd be hard to justify. One of the things that has been talked about is just the overall, how much longer a green roof may last relative to a conventional roof.
In terms of membrane life.
Right, so typically, numbers that I've heard, typical commercial roof, 25 years, 30 years. Some people have, claimed that a green roof may give you up to twice the longevity of a commercial roof. By and large, because it's keeping that surface cool, which is kind of what kills roofs, and just preventing a lot of that UV light from hitting that roof, which really tends to degrade materials. So that has to be factored in. Potential benefits of stormwater retention, which that we can talk about more. So yeah, it has to be looked at as an entire approach. Yes?
One factor you said is that it can clean the water going down. So do you test it by putting in pollutants in there and see if what the capacity is?
I'm going to defer to Debbie on that question, but that is one of the things that we're going to look at in the future. Gray water.
So if you can't sell a green roof just on R value, and R value seems to change based on other variables, what standard does one come up with
I
to be
think
able to evaluate a green roof against other alternatives?
I think economics, overall economic benefits.
So it's a total cost of ownership?
Right, so both as far as longevity of the roof, the energy savings, and the potential mitigation of stormwater runoff, and what that's going to cost you. So I think if you look at it, you have to look at the whole approach in order to sell it. Absolutely.
You said it was flat, but isn't it kind of angled really for water?
Yes, I mean, and there are green roof tray systems out there that kind of interlock and have sort of this matrix that allow you to have a fairly steep roof. I don't know if you guys are familiar with the Academy of Sciences building in San Francisco. So I mean, Renzo Piano, I believe, designed it. I mean, it looks like a rolling hills and meadows, and they designed some sort of system where there's sort of this matrix of interlocking systems, and so they pulled it off.
So do you have to put in a sprinkler system to keep the plants alive in the summertime?
Well, I believe right now you're allowed to irrigate for the first year, at least. Is that correct, as far as lead is concerned?
I think the first 2 years.
First 2 years. So,
And then you're not supposed to?
huh?
And then you're not supposed to?
I believe not. So yeah.
If you want to qualify for certain benefits that the city of Portland is offering, you have to abide by certain green roof maintenance rules, and those include you can only irrigate for the first 1 to 2 years, very low amount of irrigation, and then you're not supposed to irrigate or ever fertilize afterwards.
No fertilizer?
Yes, and I'll talk more about that.
So if my roof is shaped like this, is it possible to do a green roof on it?
Let's see, is that, what kind of pitch is that? I don't know. I'm not sure, they might be pushing it, But I've seen, I believe, Tom Lipton, I mean, he's got it on his garage, I mean, he's probably got a,
Shallow pitch.
yeah.
Yeah. Hard to keep the soil from slowing.
Right. So, but it is more so than you would otherwise think, so. All right, well, I'm gonna pass Debbie on to you guys.
Thank you.
Do you need a hand there, Debbie?
I do.
Oh, okay, Eduardo.
Yes.
You know the drill. I don't do anything around here that involves real work.
I just wanted a sample.
Okay.
And then another minute of sample of this guy. No, I meant.
Oh, you want me to collect? Okay.
Yeah, I wanted to do a color comparison.
Yeah,
Okay, so
I'm just thinking.
So to follow up on the question, can you irrigate? One of the questions we're trying to answer is, should you irrigate? Is it economically smart to irrigate? Because the amount of water you use is less than the cost of the energy you save.
Right.
Yeah, the more? Pardon me?
there is some, I'm gonna jump in, is that okay?
Please, go.
Okay, so there are some maintenance issues. This is,
Do you want to hold them?
I wanna keep them in order.
All right.
Alright, a little demo here. I'm actually running a real experiment, so timer's gonna go off soon, I'll turn the rain off. But, so, I'm testing, I'm looking at some of the water quality issues. Dr. Spolek mentioned also the storm water retention issues, which were really a bit more explored by the grad student before me. And those are pretty proven. You put soil and plants on a roof and they will retain stormwater. They will slow down the amount of water that comes off the roof and they will retain some of it. That's pretty proven. It happens every single time you put a green roof on the roof. Okay, so we know this to be true. Some of the questions that are coming up is what's the water quality that comes off the roof? Some of the water quality for the most part is improved. So when you have a normal conventional roof, you get atmospheric deposition, any pollutants in the air that will settle on that roof. And then there's the material that the roof itself is made out of, and when it rains, some of that will leach into the rainwater, and the rainwater will pick up those atmospheric deposits and wash them off into your water. There's some pretty nasty stuff in there, including carcinogens, lead, asphalt tiles. It's all over the residential areas of Portland. They have those in lead. Then you compare it to a green roof, and the main problems coming off a green roof, while they grab and hold on to the atmospheric deposition, they tend to not release that. But they do release phosphorus, nitrogen, and a couple of metals, but the metals are pretty low quantities. Copper is becoming a new issue. Phosphorus and nitrogen, you may be aware of, are there's the top 3 ingredients of what makes it fertilizer, phosphorus, nitrogen, and potassium. They're water soluble, plants need them to grow. So the people designing green roof soils are struggling with maintaining this balance of how much compost and fertilizer do we put in the soil, and how little can we put in to keep the plants happy. And the city of Portland and other cities are starting to ask questions like, what if we don't fertilize? Because we don't want people going up there and throwing fertilizer on their roof. What type of soil can we put up there to keep the plants happy? So I've started to look at water quality. This is my project. I'm looking at 2 different types of soil. I'm looking at the soil that is put on about 70% of the roofs in the Portland, Willamette Valley area. And then I took that soil and I added in a soil additive called biochar, which is basically charcoal. Okay, so I mixed it in. There's a whole bunch of buzz about biochar. People are thinking it's very new and exciting and could very well be a wonderful soil additive that we may start using worldwide. So, this is in my show and tell. I've got a tray of each in here. And just a strict visual without looking at any of the chemistry. This is the normal soil, and this is the soil with biochar. So you can tell just visually, it's a little bit cleaner, which is pretty exciting. Because this color is, we think this is humic acids. They're very large carbon-based molecules. They're harmless, but they do tend to carry with them other metals, such as phosphorus, nitrogen, copper, and other various compounds. Water of this color is deemed having a high turbidity, turbidity being a water quality parameter, and this has less turbidity, and therefore, just by visual, you can automatically say this has less of these high carbon molecules, as well as probably less phosphorus and nitrogen, but not necessarily, so we'll test that. So I've been testing that and getting some curious results. The rest of the equipment you see in this lab is my water quality analysis equipment. The total organic carbon analyzer, which is what I'm using to look at these turbidity measurements. There's a flow injection analyzer over on that table, and I use that to measure my phosphorus, nitrogen samples. And in the future, I'm hoping we are completely set up, and hopefully next year we'll be running gray water studies. So I will not be at all surprised. In fact, I would be shocked if the future of green roofs was not that we will start siphoning our gray water up to a green roof, running it through a green roof first as a primary filtration system, and then possibly reusing that water.